Dear learners, welcome to the course Electromagnetic Fields. In this video, we are going to see the topic Review of Vector Algebra. Various quantities involved in electromagnetic fields can be classified as scalar quantities and vector quantities. First, we are going to discuss about scalar quantity, a physical quantity that can be completely described by its magnitude is called a scalar quantity. Time, mass, distance, temperature, entropy, electric potential, and population are some examples for scalar quantity. A physical quantity that can be completely described by its magnitude as well as direction is called a vector. Velocity, force, displacement, and electric field intensity are some examples for vector quantity. Next, we move on to the term field. What is field? A field is a spatial distribution of a physical quantity which may or may not be a function of time. A field is a region in which a particular physical function has a value at each and every point in that region. The distribution of scalar quantity with a definite position in a space is called scalar field. The temperature of atmosphere, it has a definite value in the atmosphere, but no need of direction to specify it. Hence, it is a scalar field. The height of surface of Earth above sea level is a scalar field. Sound intensity in an auditorium, light intensity in a region, and atmospheric pressure in a given region, etc. Now, if a quantity which is specified in a region to define a field is a vector, then the corresponding field is called a vector field. Examples are gravitational force on a mass in a space is a vector field. This force has a value at various points in a space and always has a specific direction. The velocity of particles in a moving fluid, wind velocity of atmosphere, voltage gradient in a cable, displacement of a flying bird in a space, magnetic field exist from north to south field are some examples for vector field. Then we move on to the topic representation of a vector. Now we are going to discuss how to represent a vector. In a two-dimension, a vector can be represented by a straight line with an arrow in its plane. This is shown in this figure. This figure, it shows the representation of vector. So this is the starting point O and this is the terminating point A. Now it is represented as OA vector. OA vector. The length of the segment is nothing but the magnitude of the vector. This is the length of the segment. It is the magnitude of the vector. Magnitude of the vector, and it indicates the direction. This arrow indicates the direction of the vector in a given coordinate system. The vector shown in this figure is symbolically denoted as OA vector. The point O is a starting point while A is a terminating point. The distance between starting point and terminating point is distance r. It is simply r vector. Magnitude of r vector is modulus of r vector. So therefore OA vector can be represented as this is the magnitude and this is the unit vector A vector OA. Magnitude is r and the unit vector is represented as A OA vector. Generally a vector will be indicated by a letter with a bar over it. Say for example, A vector means a letter bar over it. Unit vector. A unit vector is a vector whose magnitude is always unity and it can be used to indicate the direction under the consideration of coordinate system. Here this is the starting point and this is the terminating point A. So this is unit vector which indicates the direction of OA vector. OA vector. That means a unit vector along the direction of OA. So unit vector can be obtained as a vector divided by the magnitude of the vector. Vector by magnitude of that vector. Vector is OA vector divided by the magnitude of vector is modulus of OA vector. So we consider AX vector means unit vector along X direction. The various mathematical operations such as addition, subtraction, multiplication can be performed with the vectors. In this video, scaling, addition, subtraction will be discussed one by one. First one is scaling of a vector. This is nothing but multiplication by a scalar to a vector. When a scalar is positive, then such a multiplication changes the magnitude. That means length of a vector, but not its direction. Let us consider alpha is a scalar with which vector is to be multiplied. Alpha greater than 1, then after multiplying to a vector, the magnitude of vector increases but direction remains same. Magnitude, that means the length of the vector, increases but there is no change in the direction. Similarly, if alpha less than 1, magnitude of the vector decreases and there will be no change in the direction of the vector. If alpha is equal to -1 means after multiplying to a vector, the magnitude remains same but the direction of the vector reverses. Suppose the vector direction is like this. After multiplying by alpha is equal to -1, the direction of vector reverses, but there is no change in the magnitude of the vector. Next, addition of vectors. Consider two coplanar vectors as shown in figure. Coplanar vectors means the vectors lie in the same plane. Let us find the sum of two vectors A vector and B vector which are shown in the figure. A vector and B vector. We consider these two vectors which are lying in the same plane. That's why it is called as coplanar vectors. We are going to take the sum of two vectors by two different methods. One is head-to-tail rule, another one is parallelogram rule. The procedure is to move one of the two vectors parallel to itself at the tip of the other vector. Thus moves A vector parallel to itself at the tip of B vector. Then join tip of A vector moved to the origin. This vector represents resultant, which is the addition of two vectors A vector and B vector. So this is illustrated in the figure. This is the resultant of A and B. A vector plus B vector. We must remember that the direction of C vector is from origin to the tip of the vector A vector moved. Another method of performing the addition of vector is the parallelogram rule. So first we complete the parallelogram as shown in figure by A vector and B vector. The resultant vector is C vector. Then the diagonal of the parallelogram represents the addition of two vectors. Once the coordinate systems are defined, then the vectors can be expressed in terms of the components along the axis of the coordinate system. Then by adding the corresponding components of the vectors, the components of the resultant vector, which is the addition of the vectors, can be obtained. This method is explained after the coordinate systems are discussed. These are the basic laws of algebra are obeyed by the vectors A vector, B vector and C vector. It obeys commutative law. That means A vector plus B vector is equal to B vector plus A vector. So multiplication by a scalar is nothing but alpha A vector is equal to A vector alpha. Then also it obeys associative law. A vector plus within bracket B vector plus C vector is equal to A vector plus B vector plus C vector. and also it obeys a distributive law. Alpha A vector plus B vector is equal to alpha A vector plus alpha B vector. So in this table, alpha and beta are the scalar, that is constants. Next, subtraction of vectors. The subtraction of vectors can be obtained from the rules of addition. If B vector is to be subtracted from A vector, then based on addition, it can be represented as C vector is equal to A vector plus minus B vector. So we just reverse the sign of B vector, that is reverse its direction by multiplying it with minus 1 and then add it to A vector to obtain the subtraction. These are shown in figure A and B. You notice here we change the direction of the B vector. It becomes minus B vector here. The minus B vector is here. The C vector is equal to A vector minus B vector. In this way, we obtain the subtraction of two vectors. If two vectors are said to be identical, if their difference is 0, that means A vector is equal to B vector. So, A vector minus B vector is equal to 0. That is the difference between A vector and B vector. These vectors are called as identical vectors. I hope now you are very clear about basics of vector algebra. Thank you.